Okay, so today 9.2c, last day of notes, phase shifts and reflections. Can you calm down, please? How can I incorporate the phase shifts and reflections into the transformations of stretches and compressions simultaneously? How will I remind myself to perform reflections? I think I'm going to stretch my, well, let me stretch, no. Okay, so just a reminder, phase shift takes the original point on the parent function and shifts it left or right, whatever it is, the opposite of C term over B term. And I always just like to use the point on the apparent function that's on the y-axis, and then I look to see if my new function has the correct phase shift. So remember that we're working on the equation y equals a, and then insert trig function, whichever one it is here. I'm going to write insert trig function. bx plus c plus d. Okay, so the phase shift is the opposite of c over b for any trig function. That's written in that form. Okay, so we're going to start actually with problem B. We're going to do an I do, you do, or a we do, you do. I'm going to do B because B has a reflection in it and A does not have a reflection in it. So we're going to start down here with problem B. And I'm going to ask you to remember a couple of things. So if you recall, here we have the equation y equals negative 1/2 cotangent of 1/2 x plus pi over 4. Okay, so what you need to remember is that cotangent parent function has asymptotes on the unit circle. If you recall the unit circle, cotangent is cosine over sine, right? Cotangent equals cosine over sine. And so anytime you have to divide by 0, you're going to get an asymptote for your cotangent. So for example, if we are at the point 1, 0, which is the radians, 0 radians, that's me dividing 1 by 0, which is undefined. And then if I go over here to the point negative 1, 0, which is at pi radians, and I divide negative 1 by 0, I get undefined again. So you're going to see one cycle or one phase, one cycle of the cotangent branch between those 2 points. And then, so those are 2 of the 5 critical points of cotangent with 3 points in between. And did I just lose? Okay. Sorry about that. Okay, so remember what cotangent does. It's a decreasing function from left to right. So at your, if you cut this section between your asymptotes into 4 equal sections, you start up high, hit the 0 turning point, and finish low. So your cotangent stretches like that. And so kind of zeroes out at pi over 2. And at the pi over 4 and the 3 pi over 4, you hit your amplitude, whatever that happens to be. So this is the original parent function, one branch of the cotangent function. So I'm going to start with finding the amplitude. Our A term is negative 1/2, so we're going to take the absolute value of negative 1/2, which is 1/2, and that's from the midline up and down, but it's 1/2 with a vertical flip. So that means my graph is going to move this direction. It has a vertical flip. So the top point becomes the bottom and the bottom becomes the top. So it looks like a tangent function, right? They're reciprocals. All right, so let's take a look at the period. So if I go back over here to my picture, the distance between my asymptotes is the period for one full phase or one full cycle of the cotangent function. So it has a period of pi divided by your B term, whatever that is, because that'll be your horizontal stretch or your horizontal compression. In this case, we're doing pi divided by 1/2, which is a complex fraction, so we'll just multiply by the reciprocal of 1/2. So instead of pi divided by 1/2, we'll do pi times 2, and it has a period of 2 pi. So that means my asymptotes will have a distance of 2 pi between them because you have a horizontal stretch times 2. Phase shift is the opposite of your C term over here. So negative pi over 4 over your B term. Don't forget that the B term is part of your phase shift. And again, we have a complex fraction. So keep, change, flip, or make your denominators the same. That's up to you. I'm just going to go ahead and flip over and cross simplify. So 2 goes into 4 twice, and we multiply. So that's negative pi over 2. So that means we're going to be pushing the graph left pi over 2. So our asymptotes from the original function are going to shift left pi over 2, and everything in between will also have that shift. All right, so now I'm going to do one cycle just so that I can see the horizontal shift and the horizontal stretch at the same time. And I can do everything simultaneously. I can do my amplitude and my vertical flip at the same time. So it starts originally at 0, less than your bx plus c. There's all your horizontal actions, less than pi. One cycle of the cotangent function. We're going to change the cycle by solving for x. So we'll subtract pi over 4 from each section. And we get negative pi over 4 less than half x. Less than, that's what, 4 pi over 4 minus, right, I could write that as 4 pi over 4. Minus pi over 4 is 3 pi over 4. Oh, I'm off the screen here. I'm going to stretch this out a bit so we can see a little better. How's that? Better? Yeah. Sorry about that. Okay, and then we'll multiply. I don't want to create a complex fraction, so I'm just going to multiply by the reciprocal, 2. So I can cancel. So 2 goes into 4 twice. 2 goes into 4 twice. So we have a final phase shift, or a final graph of one cycle, a pi over 2 less than x less than 3 pi over 2. Remember that these are your asymptotes after the shift and the horizontal stretch. So you can see, can you see the distance between them? Look at this distance between them. That's a distance of 2 pi. That's your period. Okay, so that's actually happening. So we're going to go to the graph now, and I'm just going to graph a picture of a cotangent function with a vertical flip and an amplitude of, oh, I probably need to stretch this over here a little bit. Yeah. So I think I'll put negative pi over 2 right here. Pi over 2, pi, 3 pi over 2. You don't have to draw multiple cycles if you don't want to. I'd like to see 2 cycles at least. All right, and I'm going to put an asymptote at negative pi over 2 and pi over 2. And then what I'm going to do is between those 2 sections, or those 2 asymptotes, I'm going to cut the graph into 4 equal sections, and I'm going to illustrate the sections, and then I'm going to erase them. So stop and watch. 1, 2, 3, 4 equal sections. You see it? We always do that between asymptotes. You want 4 equal sections for your tangent, cotangent. Now, amplitude, I'm going to go ahead and put that in. A half and negative half. Okay, and then I'm going to go ahead and draw the original cotangent function in a dashed line, and then I'm going to flip it over. If you recall, tangent starts up high on the left, closest, it's a decreasing function. So I'm going to start at my amplitude of half, and that first division, hit the 0, and then hit the bottom point, the bottom turning point. So there are your 5 critical points, and now what I'm going to do is I'm going to flip them. So this point's going to go vertically, and this point's going to go vertically, and my graph is going to do that. So maybe you want to do like just a picture of the cotangent function, just a little dashed line to show the original cotangent function, and then a solid line for the reflection of that. And then, of course, I would ask that you duplicate that cycle so that you can see a couple of sections of the graph. So it starts down low, hits the 0, goes up high, like so. And there you have the entire graph done in one step after you find all of the critical information. So do some math so that the graphing is not as complex. Do you have questions? Okay, so I challenge you then to do problem A. Press pause on the video, give it a shot, and then come back and see how you did. Okay, so we have a correction on graph B. We were supposed to have asymptotes at negative pi over 2 to 3 pi over 2. So we had to do some erasing and move the asymptote from where I originally had it here, which was not correct. I made an error. So the asymptote is at 3 pi over 2, and so you're going to cut that section into 4 equal parts, and you're going to hit your low point on your asymptote, your 0, and your high point. Not your low point on your asymptote, your low point on your graph, your 0, and your high point on the graph. So you can see the period there of 2 pi, and you have one cycle of the graph. Sorry for the mistake. Okay, and then up here at problem A, your graph should look something similar to that. I was careful on my asymptotes here and here. At 0 and pi over 2, you can see them here and here. And between the two, you have a period of pi over 2, so you can see the period pi over 2 over and over again. And you can see the amplitude stretch here, up 2, down 2 with the 0 in the middle. And so that's the graph of that with an amplitude of 2, a period of pi over 2, and a phase shift of pi over 4. And I do want to point out the phase shift because I haven't really done that yet. Typically, the tangent function, the parent function of the tangent function, will pass on the y-axis at 0, 0. That's what it does. And you can see that that point has been shifted right, pi over 4. So there's your phase shift. And if we go down here to this one, cotangent, typically at 0 is crossing the graph at 1. But in this case, it would cross at negative half because you have a vertical flip there. And then you can see, oh no, it has an asymptote. I apologize. Cotangent, boy, I'm really messing up on this graph. Cotangent has an asymptote at 0. And you can see the asymptote shifted left pi over 2. Okay? So it has an asymptote. Man, go back and do that one again. Sorry about that. Okay, it happens. All right, let's look at C and D. I'm going to do C. You're going to do D. And Isaac, did I ever answer your question?
No.
Did you? What was your question?
I was confused on the phase shift.
For A or B or both?
For A.
Do you see it now?
How is it positive? Because there's a negative.
It's the opposite of C over B.
Yeah.
So the opposite of negative pi over 2 over 2, that's a positive.
I didn't know.
Yeah, opposite of C over B. Okay, all right. Looking at problem C, we have a secant function. Now remember, secant is the reciprocal of the cosine function. And when you're graphing the secant function, what you want to do is see one full wave of the cosine function starting at the midline, hitting the peak, midline, valley. So it goes like this. So what you want to see is your cosine function in full form, one peak, one valley. So if you recall that your cosine function has a maximum on your y-axis at 0, right? Right? So if this were my x and y-axis, my cosine function would look like that. So you have an asymptote here at negative pi over 2, an asymptote here at 3 pi over 2, and then another asymptote here at pi over 2 for the secant function, because you have to take those zeros and write the reciprocal. So when you're dividing by zeros, you get undefined. So when we're looking at the secant function, we're looking for those sections between the zeros that bounce off the amplitude of your cosine function. So you'll see 3 asymptotes be 3 of the 5 critical points that you graph, and then you're going to ride the wave. You're basically going to bounce off the amplitude of the cosine wave. So there's a period here of 2 pi. You can see it. And then that's also your cycle. When you're doing your secant function, you're going to cycle between negative pi over 2 and 3 pi over 2. So let's start with our amplitude. We have an A that is negative 3. Our amplitude is 3, but we have a vertical flip or reflection. So you'll flip your cosine function upside down and then bounce your u's off of that. Your period, we're going back to the cosine function, so we're going back to a period of 2 pi divided by your b term. So 2 pi divided by the absolute value of 2 is pi. So there's a horizontal compression there of a half. Your phase shift is the opposite of your c term over your b term. So negative pi over 2 over 2. And then remember, this is a complex fraction, so maybe multiply by the reciprocal, and you get negative pi over 4. So that means you're going to push your graph left. Your asymptotes will move left. All your points are going to move left, pi over 4. And then one cycle of your graph will start at negative pi over 2. And we're going to take our horizontal action so that we can graph everything simultaneously, all of our transformations. We're going to take the original cycle, one cycle of the cosine function, and we're going to horizontally change it by subtracting pi over 2 from each section. So we get negative 2 pi over 2, which is negative pi, less than 2x, less than 2 pi over 2, which is pi. And then I'll change colors here so you can see what I'm doing here. I'm dividing by 2. And so we get a cycle that starts at pi over 2, stops at negative pi over 2, pi over 2. And just remember that that's 2 of the 3 asymptotes. There's also an asymptote in the center. So remember that. Okay. All right. So let's see. That's pretty centered. Your y axis could be centered in the center of all those points. So I'm really going to stretch this graph out. I'll only draw one cycle. My amplitude in there of 3. No, I don't want to do that. I want to double. 1, 2, 3. Be thoughtful when you're creating your secant and cosecant function, because your amplitude is going to be bouncing on the outsides of the cosine function. So you want a lot of room on the top of the graph left for your secant function. All right, so let's see. I have an asymptote here at negative pi over 2, an asymptote here at pi over 2, and then I have another one right in the center here at 0. And if I were to graph the cosine function without the shift, without the flip, it would look like this. Starts here, hits the peak with the shift left pi over 4. You see the shift, the phase shift? It's right there. It originally would be up here on the 3. So there's your phase shift. I don't know what my thing's doing here. Sorry about that. There's your phase shift. And then hit the 0, and then hit the valley, and then hit the 0. But that's if we didn't have a vertical flip, right? So this would have been the cosine function with the vertical shift and the horizontal shift and the compression. But we want the, stop it. We want to move those points and do our vertical reflection. So we're going to be working off of this graph. And we're going to be bouncing off the peaks and the valleys. And there you have a picture of your cosecant function. Right there. All done. Well, I did that one in 2 steps because I did the original cosine function and then I flipped it over. Do you have questions about that? Okay. So then you guys go ahead and do D and press pause on the video and then come back and see how you did. And then just remember that cosecant has asymptotes at 0 and 2 pi instead of negative pi over 2 and 3 pi over 2. Okay, so you had an amplitude of 1/3 with a vertical flip, period of 4 pi, phase shift of 2 pi, it's missing a little leg, 1 cycle from 2 pi to 6 pi with an asymptote dead center at 4 pi. So you can see over here between 2 pi and 6 pi, I drew in red the original sine function with an amplitude of 1/3. And then I remembered that I needed to flip it because I have a vertical flip here. And so I flipped that over and then drew the cosecant function. And then did an extra cycle here. And I also indicated the phase shift of pushing the asymptote from 0 to 2 pi. And there you go. Homework is on Canvas. It is called 9.2C. Assignment, just do all the problems on the page. Okay, so you'll have some practice to do, and then tomorrow when you come to class, make sure you're bringing your questions with you. And we'll start studying for the test.